In this video, I will provide a very quick overview of asynchronous processing and messaging. Suppose you're trying to create a new video sharing website to rival YouTube. Well, creating another YouTube is going to be a lot of work, but for now let's just consider one aspect. YouTube lets you upload a video in many file formats. For example, you could upload a Windows Media Video or WMV file from a Windows computer. But then let's just say you visit YouTube from a Mac. YouTube can't send a Mac user a WMV file. It needs to convert it to another format, say H.264 or WebM. If you've done any video conversions, you'll know that it can take a long time to translate video between file formats. Certainly more than a few minutes, and depending on the length and resolution of the video and the speed of your computer, it could take hours. So when do you think this conversion should be done? We probably can't do it when the video is about to be played, because that would mean a long wait before the video starts streaming to the user. So we really need to kick it off as soon as possible after the video is first uploaded. But then we've got some other problems. We don't want the uploader to have to wait for hours for their form submission to be successful. And also transcoding takes up a lot of CPU, and at busy times of the day, we don't want the website to get slower because there's lots of videos being converted. So please pause this video and think about how you would solve this problem. There are different ways that this problem could be solved. One approach might be to start up a separate thread on the server to do the transcoding once the file upload is complete. This solves the problem of getting back to the user quickly because the transcoding can be run and done on a separate thread. However, it doesn't deal with the challenge of slowing down the website. If many users upload videos at the same time, you could be starting lots of threads that are each doing the transcoding running at the same time. Instead, a better solution might be to have some kind of queue. When a user uploads a video, the file gets saved into the queue, and then another computer manages the conversion, working through the queue, processing video after video from the queue. And this would probably solve all the problems. But how do you think you'd make it work? How would you implement it? One approach might be to have a database table containing a list of files that need to be converted. Then you could have your transcoding service scan through the table. Details of new videos would be inserted into the table, then the transcoding server could delete the record once it's converted the video. If there's a sudden burst of many requests all at the same time, they could just build up in the table, and the transcoding service can work at a fixed rate until the backlog is cleared. So what's the point of this discussion? Well, the core idea in this situation is that we're attempting to improve responsiveness by decoupling in time the request from the processing. Our user interface code might request that some work be done at one point in time, but the actual handling of that work is done at a later point in time. You could do this by queuing up information in database tables, but Java EE provides developers alternatives in the forms of message-driven beans and asynchronous methods. Message-driven beans are asynchronously invoked. In ordinary Java code, all methods are synchronous. That means when you call a method, your code waits until the method returns. So an asynchronous method is a method that you don't have to wait for. The code returns immediately, but the processing of the method will be done later. So here's how you use message-driven beans. Instead of calling methods, you send a message to a queue. You can see here that I do some setup to establish a connection to a queue. Then once the connection is established, I can then produce messages for a message-driven bean to handle. Those messages get queued up by the application server and then are delivered separately to the message-driven bean. Here's what a message-driven bean looks like. You can see that this message-driven bean has been mapped to the same queue as before. The onMessage method is part of the message listener interface. The application server will call this method once per message. Behind the scenes, the application server manages all of the complexity for you. In fact, it is very similar to using a database table. Even if the message-driven bean crashes or your computer is restarted, the message will be delivered. The decoupling is very powerful. The message-driven bean doesn't need to be running when it has sent messages. In fact, messages can be queued up even before you've written the code for the message-driven bean that will process them. The application server will queue them up, saving them on a disk until the message-driven bean is available to process them. In addition to this durability, the application server provides a wide range of other features, such as automatic redelivery, confirmations, message filtering, and prioritization. It also supports multiple simultaneous subscribers when you use topics. If you want to learn more, then as always, I recommend the specifications. So, to conclude, if you need to decouple processing from a request, then you should use message-driven beans. The core idea is that you send messages to a queue or a topic, and then your message-driven beans process those messages at another time.